All right, so today we're going to be talking about polynomial functions. All right. Okay, 3.2, which is polynomial functions. Polynomial functions. So a polynomial function of degree n is a function of the form p of n, p of x equals a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus a sub n minus 2 x to the n minus 2 plus as many terms as you need until you get down to a1 x plus a sub 0. Okay? Now in this case, a sub n cannot be 0. Your first term can't be 0, otherwise it's going to be 0. Your numbers a1, a2, etc., all the way up to a sub n are the coefficients. Okay? A sub 0 is a constant, and a sub n x sub n is called the leading term. Okay? I know I'm getting a little on board there, and plus the thing's blocking it there. All right, so let's say, for example, I had a polynomial function such so for example 3x to the 5th plus 6x to the 4th minus 2x cubed plus x squared plus 7x minus 6. Okay? So applying this definition here, okay, we can see that minus 6 is your constant term. Okay? What would be the leading term, Jeffrey? Not just 3, it's the whole thing. 3x to the 5th, that's your leading term. Okay? It's the one with the highest. Your degree, I think most of you know this, your degree would be what, Nathan? Yeah, oh yeah, Nathan, all right, I forgot. Or did you answer already? You said 5, okay. All right, so that's good. So other Nathan, do you know another term for the leading term that would be useful? In the year? How about power function? Okay. Now that's going to be a very important thing that we're going to talk about is the power function, okay? That's going to be the term with the highest degree on it, okay? Now, some other things that we can know are the max, or the total number, I'll put the total number, no, I'm going to leave it as max. Max number of maxes and mins is your degree minus 1, okay? So if we've got a power function of 3x to the 5th, how many total peaks and valleys am I going to have demi? Okay. If my power function is 3x to the 5th, how many total peaks and valleys can I have? You can have 4 in this case. To a degree minus 1, so in this case we'll have 4. Now, let's talk about the power function units. Okay. If you were just to graph, ignoring all these other terms for a moment, okay, if you were just to graph 3x to the 5th, do you know what it would look like? Okay, so you drew it. So is it going to start high or low? It's going to start low. It's going to end high, right? Except for I'm off camera again. Okay, it's going to start low, end high. Okay, I'm going to turn this off here. Now, according to this, okay, the maximum number of maximum mins, I could have fewer than 4, but the maximum I can have is 4. Okay, so it might look something like 1, 2, 3, 4. It could look something like that. Okay, so we're looking at our maximums and our minimums. We've got 1, 2, 3, and 4. Okay, yes? Your degree is going to be the highest exponent you have. Okay, and so that's your degree, highest exponent. Your maximum is going to be whatever that is minus 1. Okay, so if I had, for example, y equals x to the 4th, Cameron, Howard.
Yes.
How many? What would that look like, first of all? Plus a bunch of other terms, let's say. Let's just talk about the power function. Well, I don't want to call it a parabola, but it'll start high, right? It'll start high, it'll end high. Okay. Now, how many turning points could I have in there?
3.
At most 3. I could have less than 3, but I will have at most 3. I could have 1, right? It could just go like this. At most, but we could have something that looks like that, right? So I've got 1, 2, 3. Now, just so you know, this is the class to prepare you for calculus. And in calculus, you'll have to figure out where these are. Okay? In our class, all we're going to care about is where does it cross 0? Okay? So if I were to redraw this a little bit differently than I did, it could, let's take the power function of 3x to the 5th, it could go 1, 2, 3, 4, 5, right? No, actually, what would be the power function for something like this? How many turning points do I have? 1, 2, 3, 4. Oh, I've got 4. Okay? So the power function for this could be y equals x to the 5th, right? And in this case, we're going to be concerned about where it crosses the x-axis. 1, 2, 3, 4, and I've got 5 in there. Yep. Okay? So you'll notice, maybe I should point that in here, your maximum number of zeros, we're going to call it zeros, is going to equal to your degree. Okay? Now, I could have, in the case of this was also an x to the 5th, right? I only have 1 in this case. It only crosses 1 time. But it could cross 1, 2, 3, 4, 5 times as well. Okay, does that make sense? So that's what we mean by maximum number. You're not going to have more than that, but you could have less. Okay? All right. Oh, let's talk about some polynomial functions. Let me come back to here. let's see, would this be a polynomial function?
Yes. Yes.
No. Why not? The reason why is because I have a sharp point on it. Polynomial functions are, we can call it smooth. Okay? So if you have a point on it, that's not going to be a polynomial function. What if I had something that looked like this? Is that a polynomial function? Michael?
Yeah.
Yes. What if I had something that looked like this? All right, let's do that. Is that a polynomial function? Cameron?
No.
No, because
I have no idea.
you have no idea. No, it's not.
No.
Anybody have an idea, Joey?
There's a hole.
Because you got a hole in it, right? It's discontinuous. So they're smooth, maybe we'll say and continuous. Okay? We've got a discontinuity there. That cannot be a polynomial function. Okay? Big jump in the graph. What about this? Is that a polynomial function? Let me see, Lauren. No, because it's a straight line. What could be a potential equation for a straight line? Y equals 3x plus 1, right? Now that's not that one. That must pretend it is for all. What would be the degree on that? The degree would be 1. Okay? So I've got a degree of 1. Is it smooth?
Yes.
It is smooth, right? Is it continuous?
Yes.
Yes. So, is there any reason not to believe this is a polynomial function? No, that is actually a polynomial function. You've got a degree 1, maximum number of turning points, or peaks and valleys. 0, doesn't have any turns in it. Maximum number of places it can cross the x-axis. 1. Okay, so that actually is a polynomial function. Okay, polynomial of degree 1, very boring polynomial function. Okay, so I know in this book they talk a lot about using a graphing calculator, but you have the policy that you can't have a graphing calculator in this class. So therefore, I won't let you use it. But let's talk about, what if I had this here? P of x equals negative 2x to the 4th plus 5x cubed plus 4x minus 7. Okay. What is the power function, Ryan?
5x.
For this equation?
Oh, no, sorry. Negative 2x to the 4th.
There we go. Y equals negative 2x to the 4th. That would be your power function. Okay? Now let's talk about the end behavior. End behavior. Okay? If you were just to draw the power function, what do you think it might look like? You're going to start high or low? It's going to start low because we've got a negative here, a negative x to the 4th. It's also going to end, and will also end low, right? Okay? looking at this, maybe it would look something like this. Okay? All right, the fact of the matter is, probably by the end of next week, we're going to learn how to factor that. Aren't you? Isn't that going to be fun? Holly's looking forward to that. Okay? All right. Okay, so I've kind of given you a lot of background information. Now we're going to try to get into the meat here. We're going to talk about real zeros of polynomials. Okay? Like I said, we're going to be most interested in this class, where does it cross the x-axis? Yeah, that will be called a zero. So these statements are all equivalent. C is a zero of P, the function P. 2, x minus C is a solution of the equation P of x equals 0. Number 3, x minus C is a factor of P of x. And number 4, C is an x-intercept of the graph of P. Okay? So as I mentioned earlier, we're going to be all about finding our x-intercepts. We also have what we call the intermediate value theorem. Okay? So this is going to be very important if P is a polynomial function and P of A and P of B have different signs, have opposite signs, let me say it that way, have opposite signs, then there exists a C between A and B for which P of C equals 0. Okay? All right, so here's what the intermediate value theorem means. Okay? Let's say I've got some sort of a polynomial function that looks like this. Okay? Let's say that this is A and this is B. Okay? So, and this is my function P. This curve is P, or P of X. I'm almost off the board. Thank you. Okay, so this is my function P. I got A, I've got a B. Okay, is the value of my P, is it positive or negative in this area? It's going to be positive, right? Is the value of my polynomial function here positive or negative? It's negative, okay? So because these two values have opposite signs, okay, Therefore, there exists at least one C. Now we can see I've got 1, 2, 3 of them in here, but there exists at least one C in between them because you've got to go from positive to negative. Okay, so there has to be 1 0 in between them. Okay, and normally you're not going to put them this far apart. You're going to, in fact, maybe you'll narrow them and just say, well, I don't want to put my B there anymore. Let's try a B here. It's still negative, right? So there exists at least one value, C, that's in between A and B, that's a 0. Does that make sense? Okay? So our job is to figure out what all these zeros are. Okay? Now, in our case, we're going to be factoring these, but I will tell you that if you get into advanced mathematics, where maybe your function's not factorable, and what you're going to do is you're going to start making that interval smaller and smaller until you converge on whatever that point is. Okay? And do that with applied mathematics. All right, so this intermediate value theorem is very important. And so let's do an example here. And I'm going to give you a nice, easy one to start off. Okay. What if I have some p of x equals x plus 2 times x minus 1 times x minus 3. Okay? Now, this is a nice factored one. We're going to want to be able to factor these in here. But my first question is, what is the power function? So, Tyler, can you tell me what you think the power function on this is? What's your highest degree in here? Well, I've actually got x times x times x, right? So yeah, so you would have a power function y equals x to the third. Okay? That's going to be very helpful for you to graph because x to the third, if you were to graph y equals x to the third, it would start high or low? It would start low and it would end high. Okay? Now let's talk about the maximum turning points, the maximum peaks and valleys. What are your maximum peaks and valleys on this curve, Maddie? 2, right? So it's 3 minus 1. So I'm going to have at most 2 turns in here. Okay? Now, because this is factored, okay, going back to our definition for real zeros, whenever the polynomial equals 0, that's where I've got a 0. So this is factored. So where are my zeros? -2. We've got 1 at -2. We've got 1 at 1. We've got 1 at 3. So this tells me how many zeros, potential zeros I could have. And in this case, I've got exactly 3. Okay? Now the question arises is, at the 0, does it touch or does it cross? Okay? How we know the answer to that question is that relates to what we call the multiplicity. Multiplicity. Okay? And we're talking about the multiplicity of each factor. Okay? If the multiplicity is even, okay, an even number, 2, 4, 6, 8, that's when it's going to cross. If the multiplicity is odd, it's going to touch. And so what I mean by that is, okay, so here we go on. So I've got 3 zeros here, -2, +1, and +3. So I'm going to mark those on here. Okay? We know it's going to start low. Now the question is, when we get to -2, what is the greatest power on this first factor, Andrew? It's 1, right? 1 is an odd or an even number?
Odd.
It's an odd number, so according to this, what happens at the 0? Oh, you know what? I wrote that backwards. Odd, odd crosses, even touches. Sorry, I wrote those backwards. Okay? So if you read the board correctly, but the board was wrong. Okay, so now, because it's odd, it crosses. Okay, so we're going to cross here. Now I'm not going to worry about how high it goes, but we're going to get to 1, which is my next 0 here. And so here, Zach, what happens? What happens at 1?
Cross.
It's also going to cross. And at 3, Riley, what happens? It's going to cross again. Okay? So it's going to look something like that. Okay? Now, I could change this slightly, and I'll use maybe a red pen. What if I put a 2 on both of those, and we were to graph them again? Nothing has changed about my zeros, but now my first 0 has a multiplicity of what, Daniel? What's the multiplicity on this factor?
It's even.
It's 2, which is an even number. That's right.
Yeah.
I've also got a multiplicity of 2, and on this one I've got multiplicity of 1. Okay? What is my power function? Who haven't I picked on yet? Debbie, have I picked on you there?
Yes.
Oh, I'll pick on you again. Okay? What would be my power function if this is my new function?
So that's kind of reading the x has 1.
So I've got x plus 2 squared, x minus 1 squared, x minus 3.
But it's going to be x or 2.
So I've got an x squared, and an x, which would be y equals x to the what power? Fifth power. Okay, so once again, power function, is that going to start high or low?
No.
It's going to start low. It's going to end high. So we've got my end behavior going on. Okay. We're going to come along to -2, right? Okay, we'll pick on Sydney. I don't think I picked on you today. So we're looking at this factor here. It has an even or an odd multiplicity. Even. So when I'm coming up here to 2, what happens? It's going to touch. Remember? Touch on even. Okay? Jeffrey.
How come on the first one on -2, it went through or across?
Because the first time there was a 1 there, right?
Okay.
Okay? I've changed the pronoun. So now we're going to touch. We're going to come here. We're going to go to +1. And what's going to happen there, Eunice, again?
So I have a question.
Okay.
Mixing the M2 into
So this is your multiplicity. Okay, your multiplicity, you have to decide, does it touch or cross the 0? Okay, how you decide, if it's even, it touches. If it's odd, it crosses. Okay, I've got an even number here. So in this case, it's going to touch. Okay, what's going to happen at 1? It's going to touch again. And at 3 is going to cross. Does that make sense? Okay, I've got my end behavior from my power function. How many zeros do I have? 3. Now how many should I have? 5, according to the power function. So I've got less than my power function says, but these are counted twice, right? If I count that 2, 4, plus 1 is 5, now it adds up to 5. Okay? All right, I haven't covered all of this. As far as the homework goes, tomorrow's quiz is going to be focused mainly on the ones that are already factored, which I believe is 9 through 29. So 9 through 29, that will be the main focus of my quiz tomorrow. See y'all tomorrow.